Okay, so this is one of those two-parters we did in class a couple of times. So it says you want to be able to withdraw 50,000 from your account each year for 25 years after you retire. So if we want to be able to withdraw every year, that's multiple withdrawals, that's going to be a payout annuity. So we have two parts. The first part's going to be a payout annuity. Okay, where we have our withdrawal amount is 50,000 each year. So K is going to equal 1 for 25 years. N is 25 after you retire. Okay, and then R here is 9%. So R is going to be 0.09. All right, so we're going to set up that formula and we're going to solve for how much we need in the account to have that goal. Let me pause this and pull up the formula real quick. Okay, so we have our formula sheet. So this is going to be a payout annuity. So here's our formula. So we'll just write everything out the way it is with our variables in place. So this is going to be P sub 0 equals D times, it's going to be 1 minus, I believe. I always get these confused. Yep, 1 minus. Oops, actually I want to replace these with my values. So instead of D, I'm going to say 50,000 times 1 minus 1 plus 0.09 over 1 to the negative 25 times 1 all over 0.09 over 1. I will use this to figure out what P sub 0 is. Let me do that real quick in the calculator. So I have 0.09 divided by 1, just going to be 0.09, plus 1. I'm going to raise that to the negative 25. So that's 1 minus that guy, 1 minus my answer. That's the whole top except for the 50,000. So I'll divide that, or I'll multiply by 50,000. And then lastly, divide by the decimal, which was 0.09. So to get what I want after retirement, I need 491,128.98. Yep. So that's what I need in my account when I retire. So then there's a second part here. So part two, is saying how much should I need to deposit each year? Deposit each year until retirement. So this is going to be an annuity problem. I'm depositing multiple times. So now my R is going to be 0.09. I'm going to write it in red now just so you see 0.09. My N, because I'm retiring in 15 years, is going to be 15 now. K is still 1. And my P sub 0 is that. Now I'm looking for D. So my annuity formula looks like this, but my final value is going to be 491,128.98 equals, I'm looking for what I deposit, D. So I have 1 plus, it's a different formula now, 0.09 over 1 to the 15 times 1 minus 1 all over 0.09 over 1. Now we'll just do it again. Figure out what D has to be. So I'll go with 0.09 divided by 1. That plus 1 raised to the power of 15 minus 1. That's the top divided by 0.09. So this equals D times that. So I'll just take that number, 491,128.98 divided by that number. I get 16,727.30. And that is your answer. This is the longest kind of question you'll see in this entire chapter and the most difficult, but that's how you do it, and that should be your answer.